Hey guys, this is the third part of video for today. We're talking about the expand and the shrink of the tubing and the rod. So as the pump is pumping down, uh, traveling valve is closing, moving down, traveling valve is closing. Remember that. So standing valve is open. So the maximum load is in the polish rod. Okay, and it causing the rod become expand. Okay, and when move to the bottom, the standing valve close. Okay, and the load is moving from the rod to tubing, and then the tubing become expand, and rod become what you call it, shrink. So this is the other way around. Okay, if the pump moves up, okay, the traveling valve close moves up, traveling valve close. Can you imagine that? And then the rod become heavy with the liquid, and then that's the maximum of the rod, and the rod become expand. And then on the bottom, the standing valve close, going downward. When moving downward, standing valve close, and then so the rod the heavy of the what you call it, the beban of the rod going to the tubing, and the tubing become what you call it, expand, and the rod becomes shrink. So the burden is going from rod to tubing, and then and then if the rod going up, if the rod is expand and the tubing is shrink, because of the load, is burdened by the rod from the tubing transport to the rod. So you can see it in the what you call it, in the video that I will share it with you. So this is how you imagine that how it works. So scat of elongated end of the tubing and the shrink of the rod, okay, become long, and then the rod. So it's much easier to see it in the video instead of just a picture, something like this. Okay, so the effective plunger is 80% of the rod length. Is part of it because of the elongated and the shrinkage of the rod and the tubing, and also because of the travel from the pump plunger. So you can see it of a travel again in the video. The effect of elongated and shrink of the tubing and rod reduce of course the stroke, and over travel is adding up the stroke. Okay, over travel of what is the over travel? So read this one. What is the over travel? It is because of the inertia elasticity of sacrot and moving up and down, and also the elongated and the shrinkage of the rod. So this is the equation of the rod of a travel. Okay, so this is the one that mentioned what is tubing pump and insert pump. And this is tubing pump, insert pump, and tubing pump or insert pump, and this is rod pump. This is a little bit different, as the on the tubing pump, every seat inside tubing. Okay, this is the advantage of a Sakrot pump, not easily to broke and simple design. But I'm not really agree with the easily to move, because if you want to install the rod pump, the base itself might take about 1 to 2 weeks, because of you have to have a what you call it, a base of the Sakarot pump is to be cemented, to be on a concrete, so to make it dry is around 2 weeks. And then yes, flexible of the production. If it's the pump is too large, you can reduce the stroke per minute, and if it's still too high, you can reduce it again by intermittent. So certain hours stop, certain hours on, certain hours stop, certain hours out. And you can analyze with dynagraph. So dynagraph is the type of graph which is analyze the performance of the Sakarot pump. You can also see it in the video, and and it's easily to see, because if you want to see is it the pump is off or not. If it's moving, means it's working. If it's stopped, it doesn't work. But if you have an intermittent setting of a rod pump, you will not see it every time it's working, because sometimes it takes about a certain hour, 6 hours, 4 hours stop, and then after that moving after you have a fluid level. Again, and then this is very cheap as compared to others, and you have it within Indonesian also. And sensitive is paraffinic. Yes, it is the disadvantage, as this is heavy and it takes a lot of places, a lot of place. But for what you call it, directional well, there is a certain what you call it, technology. You has a roller and a rod, so the roller will the rod will not destroy because of the friction of the directional. So there is a way to do this one for the directional well. Okay, yes, need a big unit for a large rig and deep well, and then a lot of problem in the what you send problem well. Okay, so it's not good in the and every well is not good in the area with this dense populated. But when I was a small, when I was a junior high, I have friends. His house is close by with a Sakarot pump. But it's a long time. Right now, it doesn't work that way. You cannot have a well in a dense populated. So the nanometer is a record of the polish rod load up and down. So a lot of nanometer. So you can see it later on in the video. Okay, let's keep it up. So I would like to skip. So just read this nanometer, how it works, and then the nanometer actually is recording up on the surface, and then with a certain algorithm, we can have the bottom hole format dynamograph. The one that's in the video mostly is in the bottom dynamo graph. So it will be different dynamograph on the bottom and the surface. This is on the surface dynamograph, and then if we transfer with a certain what you call it, a certain algorithm to become in the bottom. Okay, this is an example. This is the surface anemometer. Okay, so next time we talk about sample problem, but before we continue with sample problem, please read this, how we get the numbers. Okay, and then this is the numbers that coming with the this one. Okay, so try to understand this one. This one is the same as the previous one. Okay, so I just make it much easier, I guess. So next week we'll talk about this one plus how to calculate this one. And that's it, guys, for day one. Assalamualaikum warahmatullahi wabarakatuh.